Okay. So I'll be presenting the scene change task. And my name is Simon Brugman. I'm from the Radboud University, and this work is together with Martha. Yeah, the background you see is related to this. Okay, so this is what we'll be talking about. First, what is scene change? The motivations. Then we go concretely into the task, the evaluation metrics, related work, possible applications, other reasons why we see it's useful or how it can be applied, and a discussion. So what is scene change? Okay, given two images, one containing people, the foreground segment, and a background, change the scene of the image. So for example, I have a photo taken here in Nice. I want to change the background so that the scene is Paris. And the proposed task is that participants create faux photos, and these are photos that fool you at first, but if you look longer at them, you can see they are created images. And the fun part is with respect to the creator, so he should have improved aesthetics or like it. Faux as in the identification. And yeah, we think that, we hope that focusing on this shallow fake, this as we call it, so the when you look longer at it, that it captures distracting properties. So in that way, this is also a part of the aesthetics. Well, the motivation for this is we want to provide an alternative to the deep realism that a lot of computer vision approaches take. So we know the deep fakes, but a lot of the computer vision approaches take as an assumption that something should be photorealistic, that it should not be distinguishable from a real scene. And that's not true for humans. That's not an assumption you have to make. So there's work on this where we leverage where people leverage the flexibility of the human interpretation. So in this image, the lighting is inconsistent, and it takes participants or people who look at it on average 8 seconds to discover that here the lighting comes from a different area or different position. And this way we want to gain better understanding in what kind of deception what is there, and what kind of realism is there in multimedia. Another example is here, this orb is from the same article. On the left you see this orb with the actual reflection of the surroundings, but if you place the orb in a different environment, then mostly people don't notice that it's not a true reflection until they look for longer. So the initial task itself, we have the main task, which is the image compositing, the scene change, and a subtask. We encourage people to do background retrieval. So instead of two fixed images, choose the image that's most suitable as a background. And the second subtask to improve the foreground segmentation, as in the datasets that are currently available. The segmentation is not good enough to do it instantly. It's not perfect. We focus the task on Paris as being the most popular tourist destination, and also because there's this dataset available, the Paris dataset, which contains 10 landmarks in Paris, which is usually used for information retrieval. For the foreground segments, we propose to use the ADE 20K dataset, which has around 22,000 segmentations, of which we take the segments that contain people. So a simple example would be, we have a foreground segment, a background image, make it composite. However, as you've seen on the first slide already, possibilities are so much richer than this. So how are we planning to evaluate this? We want to do 2 perceptual user studies, in which one is time-bound and the other is not. And the question the participants will answer is, who was really there? And an algorithm that successfully produces these faux photos has a high error rate on the time-bounded experiment, but a low error rate on the unbounded experiment. For that we collected a subset of publicly available images It's called we call it the Peoples in Paris dataset of people who are in Paris, so we can compare the composite image with an actual image in Paris. There's also related work, so in compositing, so we have methods that focus on style consistency. So this is the original composite image, and they try to harmonize the lighting and the colors. You have the spatial consistency work, who try to, for example, composite an image of of glasses to a human, and then iteratively improve that. And there are combinations of that. In the information retrieval community, there's also work on gathering objects in this case. So these people, this is Abbey Road, and these people are from a data set with objects, and given the position, they retrieve the most matching object for given their approach. And applications we see, so recently there was been a lot of news on overcrowding. So the most recent one is are the Joker stairs. I don't know if anyone knows about this article. So after the movie came out, now this is a popular tourist attraction from one day to another, from being a normal street to being completely crowded. The similar case for Justin Bieber, he took a clip in this at this the waterfall, and now it's a tourist attraction with queues there. And we hope that by creating or making it easier to create these experiences where you are at this location, that it devalues for people or de-incentivizes to actually go there. Another approach, because this originated at the pixel privacy, where one approach is to use adversarial examples, so you try to attack the model specifically. While in this approach you actually remove a lot of the information, while it's also not possible for humans to detect it. So that's another application. And of course creative applications, as we saw in the initial slide. Yeah, thank you. Are there any questions?